Good morning, ladies and gentlemen. My name is Jan Sadolewski and I am head of the Conference Organizing Committee Projektowanie, Oprogramowania, Urządzeń i Systemów Kontrolno-Pomiarowych, which is also known as an English name, Design of Software for Devices and Measurement and Control Systems, edition 2023. It's my honor and pleasure to meet you today during our conference. I'm glad to see you, dear participants, and I have hope that this meeting would be valuable for you. Also, I would like to greet all participants who are watching us via the social media. So I say hello to them also. If they have any question, they can write on the chat, which is present on the YouTube channel too. Before we will go to the first presentation, let me allow to talk about our previous edition. So the previous edition takes place at the Rzeszów University of Technology in July 2012. It was 25 presentation and about 40 participants. Abstracts, presentations, and photo relation was included on the conference material, which was released on the CD disc. Current edition is held also in the Rzeszów University of Technology, but we are in the main building of the Faculty Electrical and Computer Engineering. And this edition is financed by the Minister of Education and Science of the Republic of Poland within the Regional Initiative of Excellence program for years 2019-2023. Project number 027 RID 2018-19. Amount granted with such big value for which we really appreciate. Due to international participants who came to us, we use English as the main language of our conference. Also, we know that the people who registered on this web page are watching us. So I also want to greet them because they are watching us around the world, including far Philippines, where they have afternoon. So good afternoon, Adrian, and other people who are watching there. Now I would like to show about our historical development. So these are our first achievements as the department. The department has been established in 1981. As a head of the department, Professor Leszek Trybus has been nominated. And since the beginning, the department was cooperating with the industry. They also used to do earlier with the Professor Włodzimierz Kalita. So successor also took this way to cooperate further. So to Professor Trybus, the team of Professor Trybus become larger. So in short term, Professor Marian Wysocki and Professor Jacek Kluska and Dr. Kazimierz Lal has joined him, and they were using Polish computers like Odra, to control furnaces in Zapel-Boguchwała, which is close to Rzeszów, and Katowice foundry. The feature of the left side shows engineering and data acquisition station, which was held here, and it was in the end of the 1970s. On the right side, we can see WRC Intel Gigit PI multi-channel controller, which was developed in the mid of 80s, which were used in water filtering at the Zwięczyca near Rzeszów. So it was supplying water for the citizens for many, many years. Further work of the team was also connected with the industry, and it was a ZAP factory in Ostrów Wielkopolski, which emerged into ZPDA factory Ostrów Wielkopolski. Since 90s, they were producing PSW controller, which is one of the first programmable controllers in Poland, and it was inspired by controllers which were available abroad, especially on the west side. On the right side, we can see measurement indicator, WWT, which was also developed during 90s. During ZPDA work, they produced around 1,000 of PSW devices. Control devices was not only one goal of the department. The department has also achievements in the visualization software, and this is an example of ORSA system, which was working under DOS operating system, and this screen was prepared for a heater factory in the Radom, which is also located in Poland. In the middle of the 2000s, Lumel factory from the Zielona Góra has proposed to prepare a new series of programmable microcontrollers. Meanwhile, Professor Zbigniew Świder was preparing a new series of temperature controllers, and in 2006 I joined the team, and we start to develop a software which main goal was to be compatible with the EIC 611-3 standard, who was prepared to be a way how to program universally controlled devices. After discussions, we decided to develop the virtual machine, which will be interpreting portable binary code, and our idea is presented here. It differs of the previous way when the programmers need special compiler, which was generally provided only for one particular platform. So we also had to prepare a special compiler for this and make a runtime. The runtime was responsible for interpreting of the code. Of course, it was necessary to develop IDE with syntax support to fulfill the requirements of the users. So on the right side, we can see the main window of the CPDev project, which is ST code, which can be compiled and run on the devices which are using the CPDev. Further, in 2009, Praxis Automation Technology connected with us, and in 2011, they integrated virtual machine into the marine PC computer with I/O boards. So you can see this is an I/O board, which is also equipped with the virtual machine, and on the left side we have a marine PC. The picture presents first application in Rzeszów who was prepared with Emiel, who will be the next one speaker. Further work in 2015 leads to agreement with the iGrid T&D Barcelona, and they adapted the product, which is used mainly for power plant system. Also, we will have a special presentation for this session. Of course, we also cooperate with the local industries, like company NIT from Zaczernień in Rzeszów, and also with Etronics Kraków and Bartcom from Kędzierzyn, Koźle. So we don't forget to support also our domestic producers of the devices. It was a brief history of our cooperation industry in terms of almost or more over than 40 years. It's quite a long time period, so I would like to thank the Professor Trybus for his long-term work and for providing environment for the science and industry integration. Professor is already retiring, but still has some classes with students. And as the final sentence, which I have to say why I'm here, because I was nominated to be responsible for cooperation with Praxis, and my colleague, which is a co-chairman, is responsible for cooperation with the iGrid, which is Bartosz Trybus. Anyway, before we go to the main presentation, I go to the professor and thank you personally. Okay, now the second speech.
Thank you very much, Janek. Okay, this was the first presentation, but here we are moving towards our presentation related to CPDev applications. The first presenter is Emiel from Praxis Automation Technology in Leiden, the Netherlands. He will give his speech online, but he was here in Rzeszów, I think, in 2011. But our cooperation with Praxis dates back to 2009, so I hope next year we will be celebrating the 15th anniversary of our cooperation. Emiel, are you here?
Yes, I'm here.
Okay, the floor is yours.
The floor is mine. Okay, thank you very much. Well, welcome all. Thank you for having me in your conference, and I hope that I can explain a little bit about our company and about display that the captain uses to navigate the ship. We deliver those displays. We install software, mostly our own software that we make here in the Netherlands, in Leiden, but also some software that we install from other manufacturers, such as a radar display. We don't make that, but we install it and we use it on the display that you see in this picture. There are a lot of more products that we have. I will show some of them in this next slide. You see vessel management systems, power management systems. We have a lot of different products that are used all over the ship, on many different places. The bridge is one you already noticed in the first picture, but we are all over the vessel with all of these different products. To show that more clearly, over here you can see, well, on the bridge, yes, but also in the crew rooms, also in the technical rooms, in the engine room, nearby the thrusters, there are automated systems that we deliver. All of these products we make here in the Netherlands. We even have a PCB manufacturing that we make all the PCBs inside those products here in the Netherlands in Leiden office. And for one very important part is what we get from Poland, from the university, is the CPDev. And that is a part that is installed in a lot of the products, almost all, I would say. And we use that to program them so that we can deliver the products with basic software and then fine-tune it, configure it exactly like that particular project, that particular ship needs. Using the CPDev technology, using the CPDev programmable interface. And like I said, this CPDev is in the products that you see on this picture here, but the CPDev is also in all of the products that you see in this picture, as you noticed. Maybe also the same products are in this picture as in the previous picture. You see the lever again. You see this small display coming back, and we use CPDev to make it appear in all those different cases. Same product, different purpose, different task, and we use CPDev to help doing that. Okay, then there is an important product that we have that I like to talk to you a little bit more on, to focus on, and to show a very important new development that we are doing. And this product is the dynamic positioning system. A dynamic positioning system is used on board of a sea-going vessel to keep it still, to keep it in position at a certain location. At the right side, you see such a vessel in DP mode. This is not a vessel going ahead, sailing for 10 knots speed. No, it is lying still in one position. This can be very interesting to ship off cargo, to lay cables. It can be very important to have a vessel lying still at the same position without using an anchor. No, we keep it in position using the engines, using the thrusters on board of the vessel. We do that with the cabinet that you see at the left side with the joystick. With the joystick, you can move the vessel to the left or to the right, to the front, to the aft. You can even rotate the vessel. And there are all degrees of freedom there. You can input a track to say, okay, the vessel has to sail to this point with a predefined speed. Mostly these are very, very low speeds so that the crew can do jobs like laying a cable, like getting cargo on board, off board, all kinds of tasks. You see some of those tasks here. You see at the right bottom, you see the vessel shipping of cargo to supply a platform. But also it can be from one vessel to the other, both being at the right top, both being in dynamic positioning, keeping still. Much easier than lowering an anchor. Simply pressing a button, the vessel will stay there. The other vessel can be located close next to it, and with even meter accuracy, less than a meter accuracy to keep it in one position. We use this for supply vessels. That is the example that you see at the bottom of the screen, but also the cable and pipe laying vessels, crane barges, wind turbine placement, maintenance, sometimes even yachts. All kinds of vessels use this technology to keep their vessel positioned in cases for practical usage. How do they keep position? A lot of the times they use GPS for a satellite positioning reference system. So they know within a meter accuracy, sometimes even decimeter accuracy, they know the position of the vessel. But also they can use other positioning sensors with laser sensors, with stout wiring, with hydroacoustic sensors. They know where the vessel is. We can use all of those sensors. We can read in the sensors and then decide if the vessel has to go forward, aft, sideways. And our system calculates all that different actions. For doing that, we have to get a lot of information, not only the positioning of the ship, but also trying to get information on the wind, which is with the wind sensor, on the wave with the motion sensor. And then the current is something that is calculated most of the time because there is a calculation of how much force it takes to move a vessel, and then you can also kind of subtract the wind and the wave force, and then you know, okay, the rest must be current force. There is a lot of calculating done. All this calculating we are doing in 1131 code. We call this a short name, the 1131 in our company. This is always used for the CPDev programming, but also for the DP system that we use at this moment to program this kind of tasks. And eventually the sensors are read, calculated using the control, and then eventually it will give out a set point for the thruster. I will show this a little bit better in the next picture, where you can see how this is done. We collect data, we collect input from the user using the human-machine interface, and then eventually we output to the thruster. And we output to the thruster how fast should you rotate the propeller, in which direction. And by doing that for all of the thrusters beneath the vessel, we can steer the vessel to remain exactly at a certain location, counteracting wind, waves, and current, or to even sail to a next point that the crew wants to go to, using, of course, tracking systems via the human-machine interface. At the bottom, you even see that there is, for every step that I just named, a lot of more things to tell. All the different sensors like the GPS, the gyro, motion controller, all those reference units are read in by a sensor software. These are filtered, then passed on to the control system, then the captain, the crew, they can input certain commands to say, okay, I want the vessel to sail to the right, to the left, for 1 meter, for 2 meters. This information is taken into the force calculation, and the force calculation will say, okay, then you have to push so hard to the left, or you have to force the vessel to go to the right. This information is passed forward to the thruster allocation, which divides this push request to all the thrusters beneath the ship to steer exactly the correct force for each of them. Finally, there is a thruster ramping system, because a thruster, if you want to go from 20% rotation to 50% rotation, it cannot be done within a split second. You have to ramp it. You have to slowly increase 21%, 22. And in those time, different forces are acted on the vessel. We take everything into consideration and into the calculation unit. Then there is an interesting part to come now. We want to use CPDev for a very important part of this. We are already using CPDev, as I explained, for many of our products, but for the steps that I just explained, the main calculation we use at this moment still CodeSys. And one of my projects for this future time is to switch over from the CodeSys to a CPDev system with virtual processors running on the PC. So that will be a very important step for us to do, and it kind of fits in with what we have done together with the university, together with the CPDev programmers to make possible. And you see here in this picture, it's quite a big program. Maybe you know bigger programs that can be, but for us this is quite a big programs, and we want to rewrite this program using CPDev. To do this, we need some new features into the CPDev, and we discussed this with the guys like Jan, like Bartos. We work very well together to make new features inside the CPDev. You see a little bit of code here, and I will point out some of the important parts here, the new parts, like using structures as inputs of a function blocks with arrays. That is things that were not possible a few years ago, and together we are working towards getting this kind of technology in CPDev and using them in our programs. We can use this for thrusters, steering the thrusters. We use types with structures in there. We use arrays of structures inside structures. This makes the language much more grown up, much more useful for this kind of tasks, complex tasks. I pointed out already also new parts that we helped, that we requested, and guys like Jan and Bartos and his whole team made possible for us to use. We're very happy with that. Then I will explain a little bit more about the different steps that we will take to put this dynamic positioning system into the CPDev. For this, we want to use not one program running in the Windows system. We want to use multiple programs. We want to use parts, different segments for the sensor input, different for the control, and a different section for the thruster. So with this step, first step we will do is the thruster allocation. With this step, we split up the program and we try to make it a modular system, better for debugging, better for fault checking. Yeah, what more can I say about it? The second step is the control part that we will make in this. The third step is the sensor part that we will make it. And finally, when we have this all together, it will make one complete dynamic positioning system running on the Windows PC, steering the ship, also steering outputs to the embedded units that you've seen before, which are placed nearby the thrusters on board of the ship. These systems, we deliver always our system as a redundant system. That means it exists out of multiple parts, and if one of those parts fail, if one of the marine PC fails, the other one takes over. It takes over flawlessly without bump within a few seconds. So that if a ship is doing an important job, even such a failure like a PC stopping will not interfere with the job. The job will simply continue. The ship will keep laying still even if a complete PC fails. Same for if one thruster fails, the system is smart enough to say, okay, then the other thrusters will have to do a little bit more, and we can continue the job. It's very fault tolerance. This is an important part. I wanted to mention this also. I also come now to the final sheet of my explanation, and that is an overview for this project. We want to completely go to the CPDev way of working with our dynamic positioning system. So if you have any questions about this, please let me know. Also, if you have questions now, that is, I believe, possible if I understand correctly. But if you have them later on, Yannick, he knows my email. You can ask. If you have interest in our company, you can ask. Yes, there is everything is possible. I hope you like this presentation. I hope that you like where we're going to using CPDev to replace the CodeSys, and I hope you like this product or our other products. Thank you all for having me in this presentation.
Thank you, Emiel. Thank you also for the kind words about CPDev and the work of our team. I know it was a bit diplomatic, but we like it. Are there any questions? Okay, Emiel, can you still hear me?
Yes, I can still hear you.
I would like to ask you about this multiple CPUs. You have this on your presentation.
Yes.
Are there separate CPUs or just cores of a single one?
Like this picture?
Yeah, for example.
Yes. It shows the marine PC that has inside the virtual processing units, and it has outside the thruster 1 CPU, the thruster 2 CPU. So yes, we have multiple CPUs. And each of these blue boxes, it corresponds with, and then I have to go way back to the start of my slide. So please bear with me for a moment. Then I can show you which of those products we use inside the one more back, I think. Yes, it is this processor unit at the right, at the far right, that we use to actually steer the thrusters with. And it is, of course, communicate with the Ethernet. The Ethernet is used for communication to send the thruster set points from the calculated in the Windows part, transmitted via Ethernet to this thruster unit, to this CPU, which has I/O modules that can actually send out the signals that will control the thruster, that will increase the RPMs on the propellers, that sort of things. Does that answer your question?
Yeah, perfectly. Thank you very much. Perfectly. Thank you very much once more. Okay, the next presentation will be a combined one. We are our colleagues here from iGrid from Barcelona, Spain. I think they will share the presentation together. They will do this both at the same time, I think. We have here David Root, Technical Director from iGrid, but he is also a lecturer at Technical University of Catalonia in Barcelona. And David wasn't here in Poland yet, but the other guy, Angel, he will be here in a moment, has been here for the first time in, I think, 2016, something like this, or 17, but our cooperation dates back to 2015, something like this. This was the first contact at this point. So I hope that we spend this time, these years efficiently. And David and Angel, the floor is yours.
Okay. Yeah, thanks, Bartosz and Janek and the university also to invite us to be able to show you what we can do with the CPDev. I think it's a good opportunity to show how a project inside the university has a big impact in the industry. I think this is one of the aims of the university or something, and this has been achieved here. Starting the presentation, I'm David Brew from iGrid. iGrid is part of the Tritronic group. Tritronic is a company based on Italy, which they are also in the same sector as us. We are in the energy sector, but they developed and manufacture protection devices, so power line protection devices, while we developed control devices for managing the substation. And also we provide gateways to control the substation from the control center. So we have, let's say that we are a good family in this way. I'm doing a small presentation of what we do just to give you some context of where we are using the CPDev. Okay. So in terms of using CPDev and devices sold, we are mainly selling all our devices half in Asia and half in Europe, which is mainly Italy and Spain, and also in South America. While we are focused on transmission and distribution, because iGrid T&D stands for transmission and distribution. Additionally to utilities, we also get other markets like the industry and also transportation and oil and gas. All those markets have in common that they have big energy infrastructure in terms of electricity. So there is where we are strong of. With Tritronic, we have a wide range of products, starting from the left, from protection devices, which protects the line from any fault, up to services, because there is also a company based on a service company inside the group. Here we are ranging from one side to the other, going through controllers, RTUs, gateways, HMIs and substation automation and control centers. Okay, and all those products in the middle, we are using CPDev. So every place where we need to automate something, we use CPDev on. Let's say talking a little bit what's each thing. In the left side is a protection device, it's a dedicated protected device, which used to be a small hardware to protect the line from faults. let's say, short circuits or short circuits or any kind of those faults. We have bay control units. A bay in the industry sector is the area which controls a power line going in or going out of the substation. So the substations usually have some inputs and many outputs, and each of those outputs and inputs are called a bay. So we have a bay control unit. Also RTUs and gateways. RTUs stands for Remote Terminal Unit, is an international term, which allows the control center to manage the substation remotely. Okay, this is, let's say that the RTU substitutes the human, so instead the control center can control remotely the substation. Gateways are protocol gateways because in substations we have many devices spread in the substation, and we communicate with all those devices using protocols. And also, in the other side, we communicate with the control center, so we have to also communicate with different protocols also from the control center, translate the information from one side to the other, and also to do some local processing of this information. Also, we have the SCADA, which is a SCADA focus, also developed by iGrid, and is focused on the energy sector, and control centers, which is also the same software, but in bigger scale. Here, obviously, cannot. It's nothing special to say in this case. Okay, so going deeply on how we use CPDev in our products. Let's say that we have a central software which is called IGComms. IGComms stands for iGrid Communications and handles all the information we gather from all the devices using all those protocols, which are standard protocols in the energy sector. Treat this information, and we send this information to the control center using also some of those protocols. In some cases, we need to automate the facility, and there is when we use the PLC. Okay? Let's say that the RTU, which is the unit that usually does this function, and don't need automation. I mean, many of the substations in Europe or in Asia are not using PLC. But some customers, they require PLC. They have a high degree of automation, and they need some software to do all those tasks. That's why we integrated the PLC to perform those tasks. Okay. For instance, one of those tasks is to perform some actions that the operator in the control center needs to do. But if it's done by the substation, you can recover the substation from some problem earlier because you facilitate some actions to the operator. This is directly translated in money because the utility pays for the time of the blackout. If the energy blackout is shorter, then it has to pay less, and then you get directly the return of investment in the PLC because you reduce the time of the blackout. Okay? So, because the IGComms does all those tasks and also has some internal logics built in, special for this sector, let's say that we are using a software which is running a CPU, and we are not having the same model as a standard PLC. With the PLC can run all the time with the same CPU and has all the CPU for him. In this case, we have to share the CPU with all those processors as well. So we have to have a system to integrate the PLC without affecting too much the CPU. So in one side, we have the CPDev VM running cyclically, as usual, and reading all the data from the memory, cycle by cycle. Okay? But what we added is a kind of events queue. So in a way that the PLC virtual machine can run open an event, not only cycle, but also by event. It means that we can keep a big cycle time of the PLC and then run the PLC when we need it. This is because in substations, 99% of the time, nothing happens. Everything is the same. But when it happens, we need to react very, very quickly. So at that time, we need the CPU, and we need to get results in very few milliseconds. We are talking about 2 or 3 milliseconds. We have to get a result of what happened. Okay, so here the sense is to have a big cycle. So the CPU runs once in a while, and then when we get an event, we create this buffer time, so we wait for some other events to come, because when something goes wrong in a line, we get a rush of events. So instead of running the PLC for each event, we wait a little bit for some other ones to come as well. Then we close the time window and we do the calculation once. Okay? So this allows us to manage a big amount of data with a very fast reaction time. Okay, I think this is very good to mention, because CPDev allowed us to do this kind of integrations. What is a little bit different from, let's say, from plant automation or factory plant automation is that in a substation we have values. We get values as digitals and analogs, but also we get quality and timestamp. So this is what we call a data point. Data point is not only the value, but is also the timestamp when the value changed, and also the quality. Then I will show you what's the quality of the value. Everything has to be considered in the PLC, not only the value. And so as inputs, we have signals, and also we have commands as inputs, because we can command the PLC to react in a different way. And also in outputs, we generate signals as well as a result of some calculations. And as output, we also write commands to act on the devices and on the substation. In terms of commands, we also get values, but also we have to consider the phase of the command, because the command goes through different phases. It's not just acting on the relay, closing and opening the relay, so we have a procedure to do this. And also the proper trigger commands. And another characteristic of substation automation is to be able to run multiple PLCs at the same time. Why? Because we have many times the same kind of automation. For each line, we have an automation, and all the lines are quite similar. I mean, in the substation, maybe I have 200 lines, so it makes no sense to have a big automation project with 200. It's better to develop an automation for one line and then replicate this many times. So it's much more easy to configure, and also easy to manage and maintain. So that's why then we are also running different VMs. Another reason is that we can run different automations with different priorities. Also here is important how to spend the CPU. So for with lower criticality automations, we can use a lower priority. And also we can start those VMs at different time. So when the system starts connecting with all the devices and gathering all the information. So it takes some seconds to get initialized with all this information. Then is when we start running the PLCs, but some of the PLCs need to start running at different times from the other. So then we can select when to run those. And this also, all these things are developed to make the life easier of the automation programmer. Before I was explaining that the data point is a combination of the value, times time, and quality. Okay, so in the PLC, obviously, we get into the PLC the value. We can also get into the PLC the timestamp, which can be used for calculations. But also, it's important to get into the PLC the quality. This quality are different flags that describe the quality of the value. For instance, if we have the invalid flag on, it means that the value is the latest value we've seen, but maybe it's not the real value now. Maybe we lost the connection with the device and we don't know anymore what's the real value. So then we mark the invalid, saying, okay, this is the last value I've seen, but maybe it's not the right one. So with those flags, you can decide what to do with this value. You have flags like oscillatory, so the value is changing erroneously. The value has been blocked for some reason. We detected the value has not been updated, or the value is in test mode. It means that the operator put this value in test just to test some logic. So this is also a flag that has to be considered. So the quality also can be read and get into the PLC. But you can imagine if we have thousands of data points, it means thousands of values and thousands of quality flags. This will become in thousands and thousands of variables, which could be, we can lead into very big and complex programs. So also we develop some small functions that allow to simplify those programs. So some function that says, okay, pause the PLC execution if some of those signals are invalid or are in some specific quality flag set. This simplifies a lot the code. Or block the PLC commands when some other signal is invalid. This is quite handy for the programmer. Or set the value to 0 when something is valid, because during PLC automation, usually we take values like 0 as error values. So this could be an option as well. Also, I want to show you that we are still working on doing more integrations with the CPDev. We have also redundant systems with hot standby, but now we are working quite hard in hot systems. Hot systems means that we have two units running at the same time, but only the active one is able to send commands to the field. The other one does all the calculations but doesn't send commands. Here we are also working on make the PLC of the passive one to be synchronized from the active one when it gets up. So this is something that we are working on. It's mainly work in our site, in iGrid site, because it's not affecting the VM, but all the environment around the VM has to be customized to get this information from the other side. This is a quite important job for Angel. Angel, are you here?
Yes, I'm here.
Okay. Angel is one of our colleagues in iGrid. He has been, as Bartosz said, he has been here in Poland in the first time we started integrating CPDev. Yeah, 2 times. And well, he knows very well all this integration, maybe better than me. So he's going to also to show you how we are communicating the DVM running on our devices and on what we did in the ID software. Is it, Angel?
Yeah, that's right.
Okay,
that's right.
I give you the screen to you.
Okay, let me share the screen. What's happening here? Okay, this one. Oh, it's good. Okay, can you see the screen? David, can you see the screen?
Yes, we see.
Okay. Okay, fantastic. So 1 second. Yeah. So thanks, David, to introduce me. And I want to thank particularly Jan and Bartosz just to invite us and give me the opportunity to present part of the job that, well, we have been working for the last years. So let me continue with David's presentation, explaining some bits and pieces about how CPDev is integrated with the IG comms, as David explained before, our main software. So we have a tool called iConf, it's iGrid configurator. We mainly give us, let us to set up the scenario where the different devices will be communicating, set the communications, prepare all the data points that will be shared between those devices, set up the protocol specifications. And one of the part of these things that we do with this tool is called the automations, and mainly are the PLCs. So to configure the PLCs, we use a tool that mainly is the CPDev, but customize it for us, that is called iGrid configuration PLC. And as everyone knows, with the CPDev, we configure the POUs, and for us, takes a lot of important point, the inputs, outputs, constants, and as well the retains, that these variables to be exported to be linked with our system. So considering this part, global variables in terms of the CPDev, the virtual machine for us is like a kind of black box where there are some inputs, outputs, and constants. As David said before, the IG comms can run multiple CPDev virtual machines inside our system. So user defines on the CPDev from one side these inputs, outputs, constants, and retained variables. And then using the other tool that I mentioned before, we link these variables with our IG comms data points. So how it works when the virtual machine is running. So every cycle, during the pre-cycle, the input data points, the values, are set into the input variables. Then the CPDev runs a cycle, and we check the output variables, we compare with the inputs, and those differences are the values that we set again to the output data points. So as David mentioned before, our virtual machine can work between two modes, cycle by cycle or event driven. But in each mode, every time we are setting the inputs, running the cycle, and setting the outputs again. Another important feature that we develop for our customers, and we work closely with particularly Jan and Bartosz, is to go online in order to get real-time data from IG comms. So developing this, in the next slide, we will see how we connect these parts. But what we achieved is to simulate using the real values from the IG comms, and this information is reflected in the CPDev during the online mode. Then from one side, we have part of the communication based on UDP messages. Mainly the UDP messages are to get the real-time data, but we don't send all the memory vector. We only send those changes that need to be sent. We optimize a system in order to do an algorithm, not sending too much data and sending as maximum changes as possible with the same data. And we achieve a system that is not pooling-based method. So it means that we're optimizing our system, and IG comms can run other tasks in parallel, not affecting a lot the performance of the real system. Here I put some numbers about a large project that we have been working, which is the memory map is up to 8 megabytes. So we are talking about more than 3,000 inputs and 3,000 outputs, and a cycle time based on 400 milliseconds. And at the right side of the screen, we can see, let's say, the representation of this huge amount of POUs variables that every single cycle we are setting, running the virtual machine, and setting the outputs again. Then the other part of this integration to achieve the online mode is based on web service messages. So why we develop the web service messages? First, it's because UDP is a not reliable protocol. So sometimes we need to send information that we need to be sure that achieve the destination. And mainly these web services, among other important information, is used to send first the initial memory map. So as soon as we go on online mode, we need, let's say, the first photo of the IGCOM's memory map. Once this first photo is done, using the UDP messages, what we need to send is only those changes between cycle by cycle. Other information that is already sent is the virtual machine stack pointer, the virtual machine calling stack pointer, let's say the task state, like for example, the number of cycles, current time, status. As well, we used these web services to update the PLC program if it's required. We will see an additional slide how we do this and how we improve this part. And finally, the debug mode that we will see in a short video how it works. So here I put just a small video to show how this online mode works between the IGCOMs and the CPDev. So we can see here at the top right, we have the ICOMF PLC, the CPDev. At the bottom left, we have our console that in order to show that everything is running. So at this point, we go online and we can see that this is the graphical part. These are so we can see the global variables, and we can see particularly those variables that are local variables for this POU. Mention that we can have multiple POUs open and all POUs are refreshed. So we can see multiple information at the same time. Then we can see here, I'm expanding the information, and here the input variable is false. So I'm going to go to the console and change this value to true in order to see how it changes and how the diagram is reflecting those changes. So we can see here that this line is now already set. So it means that the value is true. We are getting values from our console that are reflected directly to the global variables called count, which is increasing every time that I am just doing an update from our system. So this is done by the UDP messages and in parallel with the web service messages. Now I stop. I just put the input variable as a false, and we can see that the system doesn't have this variable as active. It is continue running because it is an oscillator, but we set the value at 38. But after that, you can see that we continue with this value, considering the previous value. Now, let me show this special feature called debug mode. So the user not only can see how the system is working, the user can develop and test and debug step by step every single part of the real scenario. So first of all, obviously, we have to go online because we need to communicate with our device. And as soon as we communicate, we have exactly the same state as before. So we go to advanced debugging. In advanced debugging, we have two additional screens. One is at the bottom left, the task information, and the right side, we can see the code view, which is ST code. It's the all ST code from all the POUs, from all the PLC projects. Now I stop the program, and in the code view, I can see where the line stopped. If I continue, everything continues, and you can see that the values are refreshed. But as well, I can put a breakpoint, and when IGCOMS reaches this breakpoint, this information is communicated directly to the CPDev using the UDP messages and the web services, and as well as the user can go step-by-step debugging. So we can see this evolution and see the global variables, the local variables. This is very useful when you are developing the program. Then, two important points that we develop in conjunction with Janek and Bartosz. Just say thanks because it was like a huge step for us. First is we had, as I mentioned before, we used the web services in order to update the PLC project. But with the old procedure, we had to stop the virtual machine, load the changes, and start the virtual machine again. So it means that the program of the PLC was stopped for a period of time. With this new procedure, we use the web services to send all the information that we need in order to change the PLC program, the memory variables, and what is required to use to continue the execution with the new changes. So what we do is during the normal execution, IGCOMS is receiving the information and save it. During the post cycle, this information is checked and updated. And as soon as all this information is already checked and updated, then during the next pre-cycle, all the information is set again, and the memory of variables is relocated, which is a really important step in order to continue the same execution with the same, let's say, memory map than the previous cycle execution. And as a result, we don't need to stop the virtual machine. Then, another important feature, the exception handler. What happened in the previous situation? So the exceptions, such as, for example, accessing to an invalid position in arrays or out of bounds, or integer division by 0, were not handled. But in the current situation, these exceptions are fully controlled, which means that the user can control the situation, and additionally, it can just develop a handler code that will be called when the exception rises. As a result of this exception, the user can, let's say, set 3 different actions for the scenario: stop the virtual machine, perform a cold restart, or perform a warm restart. So these 2 last slides, I will show you this concept of exceptions. In the first one, we will see an exception unhandled example, which means that the system handles the exception, but there is no code developed by the user that will, let's say, be executed after the exception. So it means that the virtual machine will stop directly. So again, what we need to do is, again, go online, because we need to be online in order to, to communicate with the device and see this exception. And then here is a program that is just putting values inside an array. The array has a dimension of 10, and what I'm going to put is change the array position, a position that is out of the number 10. So as soon as it happens, we can see here that we have an exception occurred window that shows us the information on the CPDev, and on the console at the bottom left, we can see the same information that says that the program stopped and there is an underlying execution. And at the end, the user can see, and in the program will see the highlighted line where this exception happened. Let's move to the next example where there is a code that handles the exception, and the user can introduce and can develop whatever needs to be done before the exception. So on the left side of the screen, we see a POU that runs exactly the same idea than before, an array, setting values on the position array, and then I'm just only moving this position of the array out of the dimension. And on the right side of the IGCOMS PLC or the CPDev, we see the exception handler code. So what I'm going to do is exactly the same. I'm going to force the system to raise an exception. In this case, I'm going to do it with advanced debugging because I want to show you specifically which actions are linked between the IGCOMS and the IGCOMS PLC. So as soon as this exception happens, we have this exception window that differs from the other one because here the user have options. The first option is to break the program. So it means that to move the code and the stack pointer to the exception handler code, and then the user can go through this exception handler code before the exception action is executed. Terminate, which means that stop the virtual machine directly, or continue, which means run the handler code directly, but not step by step or in order to debug the code. So this is mainly the part that I wanted to explain. I hope you enjoyed this part of the presentation, and I just give David the floor again. So, and if at the end of David's presentation you have any question, just feel free to ask.
Okay, thank you very much, Angel, for your explanation. Okay, so I'm part of our presentation as iGrid. We wanted to show as well where we are using CPDev. I think these are cases of success of using CPDev, which have been in everywhere where we use CPDev has been a success. But I mean, some cases, some applications where we are using CPDev on. We have been using CPDev as part of as an automation we did inside SCADA, which is in hands of controlling the generation of several power plants in Spain. Let's say that here we use an AGC block, which is developed by another university in Madrid, but this AGC is a kind of algorithm as a black box which follows the Spanish regulation and is already accepted by the transport company in Spain. So all the systems that regulate energy in Spain must follow that algorithm. So we were forced to use that algorithm, as I said, provided as a black box. But that was not enough to meet the requirements we had from the customer. So there is when we used the CPDev to customize the system to operate the plants as the customer wanted. So here we are talking about, I don't have the numbers here, but many megawatts generated in Spain, controlled, distributed in part by CPDev. Another case is the control of hydraulic power plants. This was one of the first projects where we implemented CPDev. This is much more standard or more similar programming to a factory plant. So here we are controlling the generators and the dams, and all this control is being done by CPDev. It was done by our partner in Vietnam. So he easily get into the programming environment, and he programmed mostly the whole automation by himself, very easily, let's say. Another case is energy transportation in Italy. We have a big project with the transportation utility in Italy, which is Terna. Terna requires a high degree of automation of all the substations, mainly for the criticality of those substations, because we are talking about the very high voltage lines which feed all Italy. And as you see, Italy has a geographical particularity that everything goes from, the only connection to Europe is through the Alps, and is quite linear. So this doesn't allow to refit the network from several substations, because we have the sea. So the lines here are quite important, because if you break some of those important lines, you leave the whole Italy off. So here the criticality is quite high, and Terna required a high degree of automation, up to the point that the automation projects we implemented inside the PLC were given by the utility. So the utility has certified some programs in ST, and they provided us as is, and we integrated them. Well, we compile it inside the CPDev as used as it is, because they really have those algorithms well tested. Another case of use is a very nice project we have in the Alps in Italy as well, where we are supervising the high voltage towers. So we are getting all the data from those towers, and those towers are remotely spread and are very difficult to communicate each other. So here we developed an IoT project using LoRa radio and also MQTT and 4G to get all this data from the towers, process this data locally with CPDev, and then the results of this processing is being sent with those LoRa radios, which transmit very few data in a long period. This is because is the way it works, LoRa. So it allows you to have a big network, but with a very low bandwidth. So this was a kind of handicap in this project. Okay. So we used CPDev in no IoT project as well. And also another sector which is quite similar to the distribution sector is the rail sector, which they need the power lines to feed the trains. So they also have substations, and they have some local automations that we need to accomplish with the CPDev. We had very good projects in Spain and in Italy mainly, using also CPDev inside our devices. Okay. And that's it. I think these are the cases that I think are representative of using CPDev in the energy sector.
Thank you, David. We are now opening questions, so there is a little bit time for discussion panel. So if there is any question on the room.
Let me ask, we help you implementing this on-the-fly update, which means that you can upload a new version of the software to a running system. Can you say a bit what is the requirement of such behavior? Why do we need to do this without stopping?
And this is because we have a specific project which is monitoring all the substation, and to set it up and running, it takes some time. So there is a kind of time filterings that are being calculated during the process. So the customer wanted to adjust the program at that point without restarting everything from scratch, because every time that we need to go back, it means that to start again, to position the substation in a certain state, and to simulate again all the stuff. So for him was quite important to be able to adjust the program on the while. So that was the requirement. I think we have to think that operating a substation is not an easy thing. We have to consider that we have to get permission from the control center, saying that we are going to operate the substation. You cannot say it in one day or today, hey, I'm going to control the substation. No, we have to say it in advance, because there is a plan of, in case of failure, there is a recovery plan. Some other substations need to be ready and needs to be coordinated with other works done in some other substations. So there is a lot of requirements before acting on a substation. And when you work in the substation, you have a time window. So if you ask to do some task during 3 hours, you only get those 3 hours. Then you have to put back the substation in production after those 3 hours. So it's quite strict. You don't have the automation for the substation for your own, and you cannot do whatever you want. And obviously, because we are working with energy, and every operation you do has to be very, very well calculated and to not damage anything. You can burn a line, or you can exploit a transformer, or you can make very big damages also. Translated in cost, it could be quite high, you know. So this is quite procedimental task that before doing any action needs a lot of paperwork and considerations. So that's why this customer wanted to update, during those works, wanted to update the program to adjust, to tuning a little bit without restarting the whole system, because not the matter of restarting the PLC, but also the communication, the whole IG comms and all the communication with all the devices. Okay, thank you.
Thank you very much. As the team that was referenced to in your speech, we would like to thank you very much for having the opportunity to work with you, also with Praxis, with Emiel. We, as the university guys, are often thought as people who work only in the theoretical aspects of science, but it is our pleasure to have to see our ideas applied actually in industry. Thank you very much, and also David, thank you for coming in person here. Angel, thank you very much for good cooperation on, I think, day-by-day basis. Okay, thank you.
Now it's time for a coffee break. So you are invited outside where is service. Thank you.
Just a moment. At 12:15 we have the second session, which will be started by Professor Nino Topuria from Georgia. She will say something about AI Builder. I think it will be very interesting presentation, but we also have 2 speeches of our colleagues from the team. First from Marcin Hubacz, which will say something about problems with data alignment on some particular CPUs, especially ARM-based. Am I right, Marcin? And then we have Andrzej Stec, who will say a few words about motorboat and autopilot of the motorboat. Thank you, and we invite you for the next session, which starts at 12:15. See you there. Then. Okay, hello again, and a special welcome to the new listeners, especially our students. Hello. We have 3 presentations in this session, which is called Applications and Performance. And please welcome our first guest, Nino Topuria from Georgian American University, which is visiting us in terms of Erasmus project. Okay, the floor is yours.
It is with great pleasure that I am standing before you today. This is my first visit to the city of Rzeszów, and I was fascinated with this small and the same time culturally rich city. I would say that Rzeszów is the hub of academic and technological advancement. Thank you. Now, my presentation. Introduction to AI Builder. This definition from Microsoft documentation, and I read it. AI Builder is a Microsoft Power Platform capability that helps you improve your business performance by automating processes and predicting outcomes. By using AI Builder, you can quickly bring artificial intelligence to your apps and flows that connect to your business data that is stored in the underlying data platforms such as Dataverse or in the various cloud data sources such as SharePoint, OneDrive, or Azure. How and where can we find AI Builder? This is under Office 3065 subscription and under Power Platform. Power Platform consists Power BI, application Power BI for business analytics, Power Apps for app development, Power Automate for process automation, Power Virtual Agents for intelligent virtual agents, and Power Pages. Okay. Office 3065 users can access Microsoft Power Platform with their Office 3065 credentials, offering a seamless and consistent sign-on experience. AI Builder simplifies the AI creation experience by giving people with any level of technical skills the ability to add AI capabilities to their apps and flows without writing code. This is low-code platform. What you can do with AI Builder? You can use AI Builder to create custom AI models that suit the needs of your business, or you can choose from a selection of pre-built models. You can then use the AI from these models in your apps and workflows. Custom AI models. This is a list of custom AI models. Prediction. To predict the future outcomes, for processing, for analyze and extract key value pairs from documents and images with machine learning technologies, object detection, to speed up or automate business processes, category classification allows you to analyze large volumes of text data in the form of email or social media, entity extraction to recognize the data based on your business needs. Then we have pre-built AI models. First, business card reader. This is a model allows you to extract information from business card images. Text recognition model allows you to extract words from images and documents. Category classification, key phrase extraction. All this information from Microsoft documentation. and then I explain all this in practice. Language detection allows you to detect language of text document. Sentiment analysis, you detect positive, negative, and neutral and mixed sentiments in the text. And now, how can we use first model? First of all, we have two classes of model. Models that require customization before they can be used, and models that are pre-built and can be used right away. This is a list of AI models, and then common business scenarios. Automate customer application processing, model type, form processing, automate expense reports, then categorize use feedbacks based on the focus, and so on. Please, this is please read this. Okay. How we launch AI Builder? Okay. First of all, presentation, and then choose AI model type. Use the model type that suits your business needs. Then connect to data. Select your business-specific data from available options. Tailor your AI model. Train your AI model, and use insights from your AI model. So, AI Builder sentiment analysis is a pre-built AI model that identifies that the sentiment of the entered text is positive, negative, or neutral. AI models usually require that you provide samples of your data to train before being able to perform predictions. And I want... I need... No, I need Google. Chrome is active. Yes. How can we launch this? First of all, portal, Office.com, then here, choose Power Automate or Power App. I choose Power Automate. AI models, built-in. New AI model. Here we have templates. And for documents, all, choose all. But it's not work properly. Oh, yes. We have a sentiment analysis detect. Here we have 500 random samples, and we can check random sample. My device stopped working after only 2 months. Analyze. It's negative 70%. Another example. I did not get a response back from customer support. Analyze. It's negative 92%. And once more. Power in Seattle has been restored in 24 hours. Analyze. Neutral by 90-20%. Okay. Now we want to bring this AI model in our flow. Using a flow or using an app? Using a flow. Okay. We can create from blank instant cloud flow, named it test maybe. And how we want to trigger a flow, manually trigger a flow, choose, then create. Manually trigger a flow. Add input, text, it's my text, and then text. Add an action. Then we want AI builder. Right here. See more. Analyze positive or negative sentiment in text. Add in app. We can choose language. Dutch, English, French, German, and so on. Polish and Georgian not listed. Okay, we choose English. Select one. Here we have dynamic content. And we choose my text. That add an action. Excel. OneDrive Excel. Add a row in the table, okay? And then we need an Excel file which must be created in advance. How our flow work? I open the flow. It is not. I open my ready-to-use flow. Analyze text. write text. Maybe weather is good. Run flow. And done. We need this positive. Then I close this one. I lost. Analyze. Done. This one, I think. And then how can we feel? How we have to feel this? A location, OneDrive for business, document library, OneDrive, file, book for sentiment, which is in advance, get ready in advance, table, name of the table, and then you have to fill this form. And how I can. I need presentation. Yes. Okay. Sentiment analysis have many possible applications for your businesses include analyze sentiment of your brand by using data from social media and trigger an alert from negative customer entires, send an automatic response to negative customer feedback from surveys, analyze trends on user sentiment for each product, geography, customer representative, and so on. Check the sentiment of your email before sending it to an important customer. This is the full description. How can you use AI Builder? If you are interested, I can share this presentation. Okay, this is the screenshot of our Excel file. This is how I design this flow. First of all, you need to choose how we want trigger a flow. In my case, this is a manually trigger a flow. Then you have to choose an AI model, and then you have to fill this form. In that column, you have to write sentence sentiment. Probably sentence is positive, probably sentence is neutral. These options are available from dynamic content. This is questions. What are the possible outputs of sentiment analysis models? We know that this is positive, negative, neutral, or mixed. Where can we use sentiment analysis? Both Power Automate and Power Apps. Power Automate for workflows and Power App for mobile application. Which of the following business scenarios can be supported by sentiment analysis? Analyzing customer feedback and surveys, analyzing social media, analyzing emails and other unstructured text, analyzing employee sentiments. All of the above is the right answer. Introduction to AI Builder Business Card. This is another example how can we use AI how can we use business card reading in our mobile application. This is description already. The pre-built business card AI model allows you to extract information from business card images. If it detects a business card in the image, the AI model extracts the information such as name, job title, etc., and so on. In AI Builder, you have access to a wide range of different business card designs and formats. Business cards are supported in English language only. More languages and file form will be added in the future. You can use business card hidden in your model-driven apps, Canvas apps, and Power Automate flows. Okay, how can we design our mobile application? This is full overview. Select insert a new form, edit in edit mode. I do this. A launch Power App. Power App we have under Office 365 subscription is Power Automate. Only what we want, what we need. Here we have an AI Builder and choose AI model named Business Card Model from the list. This is a library of AI models. And insert here. Now I delete it, okay? Then we have add-ons menu and ideas and properties. You have to do connection with any database. In our example, we choose Dataverse. Here. Test our application. Oh, I forgot. Here is the button. This is code for submit this form. Okay, test our application. We need some business card. Maybe I find in Google business card example. My business cards maybe. We need high resolution image. Choose which one. We can test this one, I think. Save image as. And save. Okay. This one. Next one. Here we have not email. Next one. This card. Not working because resolution not so good. Okay. And I choose first image, this image, and I choose create contact button. This is a table of data wares. I lost mouse. Oh, no. Yes. Write the contact table. You know that everything is okay. Okay. Help. I need presentation. Okay. This. Oh. Nice present. I need this. AI builder. This one, yes. Okay. Sales results is the contact table. Why use Dataverse? Standard and custom tables within Dataverse provide a secure and cloud-based storage option for your data. Tables let you create a business-focused definition of your organization's data for use within apps. Okay, this full description. How can you build mobile application with AI model? You have to write this code here, which business card reader 1, call AI model, and full name is the field. Then call business card reader AI model and write email, and then call business card reader AI model and write business phone. And how it works. Add a button to trigger the creation of a new contact. You have to write submit form. Create contact, create, submit form. Okay. As a conclusion, the benefits of using Microsoft AI Builder: increased efficiency, data insights, and improved decision making. And key features and functionality of Microsoft AI Builder: drag and drop interface, no coding required to build AI models. Maybe some code requires. Pre-built AI models, ready-to-use models for common scenarios, and custom model training, train models using your own data. As a conclusion, AI Builder offers companies these capabilities. We recommend mid-sized companies start using Power Automate with AI Builder to automate as many of their business processes as possible. You know, Gartner publisher refers to this view of automation as a hyper-automation, that is a company automates everything that can be automated. Thank you very much.
Okay, there is a time for questions. Is there any question on the room? I have one. Okay, do you think that it can be possible to use the artificial intelligence in some critical systems? Because we are talking about business systems which are not usually critical. What about a situation when
For critical situation, we use a platform is called IoT Central. This is a platform, maybe I show. This is a platform where you tested many IoTs, and you can build in IoTs in your application or your system. And these AI models only for routine tasks and for not for critical situation.
Okay, thank you.
And I show you Microsoft mouse. with Google.
On the seconds. Which page? Because Control Tab you will this one. Look at this one or not?
But I don't.
OneDrive?
No. Only Google.
Only Google.
Yes.
So new page.
Sometimes I lost mouse.
Yeah, you can type.
Azure, IoT, Central. Internet.
Yeah, the first.
IoT solution development. I cannot see it.
Okay, maybe you will answer later.
Okay.
Because we have a next presentation.
I find this and
Yes, I will prepare a new environment for you during the break. So thank you once again for your presentation. And now we will switch the computers.
Okay, the next presenter is Marcin Hubacz from our university and our faculty, also department. He will talk about impact of data alignment for embedded CPU's performance. Okay, Marcin, the floor is yours.
Okay. F11. Full screen, pamiętam. Okay. Hello, ladies and gentlemen. My name is Marcin Hubacz, and I work in the Department Computer of Control Engineering. During today's speech, I will present the topic impact of data alignment for embedded performance. I cordially invite you. I will start from the agenda. First, we will deal with a genesis of problem. I say a few words about test platforms, and I will say move on limitation and memory access and method of data access, ending with the result and conclusions about these tests. Okay, maybe I repeated some information, but what is CPDev and what is advantages in industry is standardization ESE 61131. And the open source code is virtual machine, allows you customize it your needs. Okay, the execution environment is multi-platform because it's written in C, so you customize to every platform if you need. And calculation activated periodically or on demand. Okay. Basically, we have two methods, two different paths creating software for industrial controllers. We can run identical code on three different platforms, maybe differ in processor, disks, maybe extension modules, maybe operating systems. So let's start from the right side. Okay, the code in the C language is translation to code in C. Then the generate code is compiled to the binary codes, three binary codes, compatible with the given the platform, hardware platform, and each operation must require compilator with specific settings, and deployment for this platform must be free. Okay, second solution of this is different in the left. Here, this is the language is compiled into a portable code, binary code, can be run on any hardware platform. The condition for launching is one-time preparation virtual machine on this platform. So software distribution is maybe optimized and distributed as a broadcast. As stated in the introduction, the CPDev environment is a multi-platform solution. May be run on classic platforms how x86, x64, and ARM, and also microcontrollers may be ARM, MIPS, AVR, Xtensor, RISC-V, and others. Maybe run on operating systems such as Windows, Windows Embedded, IoT, FreeRTOS, Linux, or in bare metal solution. The QR code redirects the product on GitHub, where can view example implementation and code virtual machine CPDev. Okay. On the screen, we see the basically diagram with CPDev virtual machine. This solution is divided into three phases: pre-cycle, VM task cycle, and post-cycle. Memory operation impacted the performance and correct working of the virtual machine. A particularly important element is introduction processor unit in the circuit files. I will add the code memory. Contains instruction, and data memory contains variables of control program. The instruction processing regularly reads or writes data from code and data memory. So the data memory consists of this data. For the reason the variable have been grouped into 1, 2, 4, and 8 bytes, because from the point of view of memory access, only size and addresses matter. Character strings consist 1 or 2 bytes. Data memory may consist of randomly or distributed in the space. This is addresses in the space, maybe RAM as processor. When executing virtual machine instruction on ARM, there were problems with accessing some variables. After the analysis different architecture from ARM family, the set rules was prepared. From some architecture is required to keep as addresses divisible without remainder by their size. So on the upper left we see correct, but upper right incorrect alignment data. Examples, this means for 2 bytes maybe addresses on 0, 2, 4, but 4 bytes you must place on or 0 but 4. The example at the bottom shows correct and incorrect arrangement variables memory. In both cases, this same structure is represented by different arrangement data. The system was tested in 3 memory access methods: byte access, so byte by byte reading data, and the variables larger 1 bytes, more composed from more bytes. Memcopy, so function from C string library, and direct, so direct access via pointer and size. Each method tested with 2 types data arrangement. One unalignment, so it's randomly arrangement data, and alignment for full words, full words, so 4 bytes. This is a table with tested platforms. So we have many platforms, microcontrollers with ARM and MIPS, 106 micro, Extensor, X5, and Intel Quark, and ARM for microprocessors, so tested with operating system. Okay. This is the results for microcontrollers. In the table presented missing bars for some microcontrollers for indicate incorrect operation, direct access, and alignment data, generating processor errors. These platforms are here. In most cases, direct access is several better percent than copy, and for most platforms, byte access is twice as long other methods. The last chip, SR2NV, from Intel is very interesting because we have similar results for all methods. Copying and writing data. Okay, this is a microprocessors. Byte access approximately double cycle time compared to other methods, and direct access was several percent better out of than memcopy, and all tested access methods work correctly. We will now move to general results for prepared memory access methods. To unsafe method for unalignment data with direct access method was omitted in a summary because it's unsafe. The byte access method turned out to be longest. This in this, and memcopy method generates similar results for 2 arrangement memory, and alignment direct access is the best for microcontrollers if we can use them. Okay, but we use microprocessors. We have byte access is not recommended for this because it's the double twice memcopy or direct access. Okay, conclusions. Byte access is extended to circuit calculation times, is so not recommended for using in implementation, but correct regardless of the platform. Memcopy is optimized for the platform over compilation, and correct regardless of the platform. So it's the best universal and safe method copying, but direct is shorter calculated times, but maybe a lot of memory because data is alignment to 4 bytes, and hardware incompatibility issue with older architecture, my AVR, but older ARM. Thank you very much.
Thank you, Marcin, for your speech. Is there any questions on the tape room? Yes. David, please.
Yes. As I know, the memcopy function for copying small memory portions like 1 byte, 2 bytes, 4 or 8, I think it has a high overheat of preparing some internal stuff before doing the copy. So can we see this difference, this overhead produced by the memcopy function compared with the byte by byte copy?
Byte by byte copy is adding for 2 bytes copy 1 byte and add with does, but when we memcopy is optimized by compilate for the given platform, and we using specific settings for the platform, and we as a result is so better than byte.
Just a comment to your question. As we see, we have different problems with different platforms. So actually, the virtual machine can be configured to either of the 3 ways of accessing data. So it's up to the person who ports the machine to the particular platform which method they will choose. They can even select byte
access
if this is enough for a particular platform. And also, Marcin didn't mention this, but we have this endianness problem for different processors. So most of them are little endian, but some are still big endian. So we have to reverse the order of the bytes, and there is no way doing it other than by reading each byte independently. Okay.
Thank you.
Okay, thank you very much once more, Marcin.
Thank you. Thanks.
And the third presentation in this session will be by Andrzej Stec. And here is a small remark for our guests from abroad, either from the industry or from the Erasmus program. It will be for you the chance to learn some Polish. So if you don't understand something, just ask what does it mean, and I think Andrzej will explain. Andrzej, the floor is yours.
Szanowni Państwo, chciałbym przedstawić pewien projekt, który obecnie realizujemy. Ten projekt jest związany z autopilotem łodzi motorowej, który jest dodatkowo wyposażony w interfejs HMI. A króciutko plan wystąpienia. Na początek powiem o założeniach projektu, co przyświecało nam przy jego tworzeniu, opracowywaniu. Następnie przejdę do ogólnej architektury systemu, z czego się składa, z jakich elementów. Krótko powiem na temat autopilota, który został opracowany jeszcze w środowisku CPDev i również został zaimplementowany, choć nie do końca jeszcze przetestowany na takich warunkach rzeczywistych na wodzie. Powiem krótko o identyfikacji obiektu, która jest związana z doborem nastaw regulatora, no i parę słów na temat komunikacji MQTT, która jest wykorzystana do wymiany informacji pomiędzy urządzeniami działającymi na tej łodzi. I na końcu krótkie podsumowanie. Tak jak już powiedziałem, celem naszego projektu było opracowanie automatycznego sterowania no, czyli po prostu autopilota dla łodzi motorowej, dwusilnikowej z silnikami elektrycznymi. No, co potrzebowaliśmy, co wykorzystaliśmy? Wykorzystaliśmy zwykłą wódkę wędkarską, która ma możliwość zamontowania silników zaburtowych. Wymagało to pewnych przeróbek, bo zazwyczaj takie łódki wędkarskie mają możliwość zamontowania tylko i wyłącznie jednego silnika. W związku z tym trzeba było zrobić tam pewną przeróbkę, żeby dało się zamontować dwa silniki elektryczne, zaburtowe, które po prostu zostały zakupione w sklepie. Oczywiście zasilanie akumulatorowe, no dosyć duże, 2 akumulatory, ponieważ chcieliśmy, żeby było to lekkie, zastosowaliśmy 2 akumulatory litowo-jonowe o mocy, czy powiedzmy o prądzie, no, po pojemności 116 Ah każdy. Oczywiście konieczne było wykonanie sterowników mikroprocesorowych i te sterowniki mikroprocesorowe zostały wykonane na bazie modułów M5 Stack oraz Raspberry uzupełnione o wyświetlacz LCD. Jeśli chodzi o wymagania, które ma spełniać ten system, no, ma przede wszystkim sterować łodzią, ale w 2 trybach, w trybie ręcznym oraz w trybie automatycznym. W tym trybie ręcznym no to jest zwykłe przekazywanie sterowania do silników, no tak albo jednym, albo drugim, w zależności od tego, jakie jest rozłożenie tego sterowania, to łódka będzie skręcała albo w jedną stronę, albo w drugą, albo będzie płynęła na wprost. Oczywiście również ten podstawowy tryb to będzie tryb automatyczny z autopilotem. Dodatkowo chcieliśmy wyposażyć ten system w interfejs HMI, tak aby sterowanie, operowanie łodzią było wygodniejsze. No i komunikacja miała się odbywać w sposób bezprzewodowy między urządzeniami. Dlaczego tak? No chcieliśmy unikać po prostu kabli. Ten system jest mały, przenośny, w związku z tym jest montowany i demontowany za każdym razem, kiedy się wypływa na wodę, stąd też no, założyliśmy, że będzie to komunikacja bezprzewodowa i jednocześnie chcieliśmy sprawdzić, czy taka komunikacja bezprzewodowa będzie miała sens, czy się dają zrealizować i czy no, te czasy związane z komunikacją, z przesyłaniem komunikatów nie będą zbyt długie. Powiedziałem krótko, że są silniki elektryczne zaburtowe. Wybraliśmy silniki Haswing ProTruar 4.0G. Są to silniki już bezszczotkowe, no, chłodzone wodą, bo ten silnik jest zanurzony w wodzie. Zasilanie 24 V, moc 1800 W, więc już całkiem mocne. Maksymalny prąd to 75 A, uciąg 130 funtów. Średnica śruby to 30 cm, 3-łopatkowa śruba, ciężar każdego silnika to no, troszeczkę ponad 8 kg. No, 2 takie silniki będą konieczne. Oprócz tego akumulatory litowo-jonowe 7S o napięciu 24 V, tam 25,4 V w rzeczywistości, pojemność 116 Ah. Oczywiście tego silnika wprost nie można wykorzystać w systemie z tego względu, że on ma zwykły taki rumpel, to się nazywa właśnie rumpel, natomiast my chcemy sterować nim w sposób bezprzewodowy z komputera pokładowego, w związku z tym ten rumpel musi być zastąpiony naszym sterownikiem. Ogólna struktura systemu została tutaj pokazana na slajdzie. Jego głównymi elementami jest komputer pokładowy, który również pełni funkcję autopilota. Bazuje on na module M5 Stack. Oczywiście no, jest ten interfejs HMI, który został wykonany na bazie Raspberry i uzupełniony o wyświetlacz 7-calowy LCD. Dodatkowo oczywiście te silniki, o których już wspomniałem, i moduł sterownika silnika napędowego bazujący na module też M5 Stack. Ten moduł M5 Stack musi być uzupełniony jeszcze o dodatkową płytkę, która pozwala na podłączenie się w tym miejscu tego rumpla po to, żeby przekazać sterowanie do modułu elektronicznego, który jest modułem oryginalnym. Tutaj niczego nie zmienialiśmy. Tak, nawiasem mówiąc powiem, że chodzi tutaj o zmianę rezystancji. W tym modelu silnika sterowanie polega na zmianie rezystancji, która powoduje, że silnik się kręci szybciej albo wolniej. Jeśli chodzi o komunikację, no to jest tutaj wykorzystywany broker MQTT. Aktualnie ten broker jest już tutaj zintegrowany z tym panelem HMI, z interfejsem HMI. Docelowo planujemy, żeby był on niezależny po to, żeby nie było konieczne korzystanie z HMI, jeżeli nie będzie takiej chęci ze strony użytkownika. Ten interfejs HMI ma możliwość sterowania zdalnego autopilotem, ale ma możliwość również obsługiwania mapy. W związku z tym, ale jednak, żeby można było z tego skorzystać, no niestety musimy mieć dostęp do internetu i ten dostęp do internetu zapewniamy z poziomu smartfona. Jeśli chodzi o sterownik napędowy, no to już powiedziałem, że rumpel silnika musi być zastąpiony, no bo tam się po prostu obraca tym rumplem w jedną stronę, w drugą i w ten sposób silnik kręci się szybciej albo wolniej w jedną albo w drugą stronę. No tutaj zastąpiliśmy ten rumpel swoim sterownikiem. Jednocześnie ten moduł służy nam również do pomiaru prądu i napięcia zasilania akumulatora. Jest to informacja, która może być dodatkowo wykorzystywana w autopilocie do doboru sterowania, ponieważ nie mamy możliwości pomiaru prędkości obrotowej silnika. Możemy to robić jedynie zastępczo poprzez pomiar prądu zasilania tego całego silnika, aczkolwiek elektronika zajmuje stosunkowo niewiele, bierze niewiele prądu. Komunikacja bezprzewodowa oczywiście z komputerem pokładowym. Te sterowniki mają możliwość podłączenia interfejsu przewodowego, na przykład interfejsu CAN, ale na razie tego nie robiliśmy. Myślę, że zrobimy to kiedyś również jako alternatywę. No i chcemy, aby sterowanie było możliwe jako lokalne albo zdalne, czyli żeby w przypadku jakiejś awarii zasilania, może nie zasilania, awarii komunikacji, żeby można było ręcznie sobie posterować, natomiast jeżeli wszystko jest w porządku, to może to sterowanie realizować komputer pokładowy. Komputer pokładowy też bazuje na module M5 Stack, troszeczkę starszej wersji Grey i dodatkowo ma on na sobie jeszcze moduły, moduł GPS oraz moduł IMU, z tym, że moduł IMU jest oryginalnie już wewnątrz tego modułu M5 Stack. No i zadaniem jego jest sterowanie silnikami napędowymi i jednocześnie współpraca z interfejsem HMI. Na tym module również jest uruchomiony program Autopilota. No i oczywiście, tak jak każde inne urządzenie, obsługuje komunikację z urządzeniami pokładowymi, tymi pozostałymi, czyli sterownikami silników napędowych oraz interfejsem czy panelem HMI. Tak jak powiedziałem wcześniej, wykorzystujemy czy próbujemy wykorzystać komunikację MQTT. O tym jeszcze parę słów powiem później. Dodatkowo, to już tak dla celów, takich troszkę może badań naukowych, rejestrujemy dane na karcie SD, aby po przeprowadzeniu takich testów można było przeanalizować to, co się działo i wyciągnąć wnioski na przyszłość. Interfejs HMI został opracowany przez jednego z naszych studentów, przez Rafała Nazarko, być może Państwo go znają. Jest w tej chwili na studiach 2. stopnia i Ta aplikacja, no bo powiedzmy ten interfejs, ten panel to nie sama aplikacja, tak? Tu jeszcze dochodzi sprzęt, na którym jest uruchomiony, czyli Raspberry oraz wyświetlacz LCD, ale sama aplikacja jest aplikacją wieloplatformową z interfejsem graficznym po to, żeby można było wygodniej obsługiwać cały system. Ten wyświetlacz LCD 7-calowy ma możliwość obsługi ekranu dotykowego, jest możliwość również podłączenia niewielkiej klawiatury, można podłączyć myszkę, w związku z tym obsługa, można powiedzieć, może się odbywać w dowolny sposób, również taki klasyczny, tradycyjny. No oczywiście taka zwykła, klasyczna myszka może być niewygodna, ale klawiaturka taka mała, której tutaj nie pokazywałem, jest jak najbardziej wygodna. Możemy przełączać się pomiędzy różnymi trybami pracy ręcznej, pracy automatycznej. W tej chwili jest tutaj pokazana, czy w zasadzie jest to zrzut ekranu taki bezpośrednio uruchomiony nie na łodzi, tylko na symulatorze, w związku z tym są to wartości zerowe. Nie o to chodzi, chodzi o pokazanie jak gdyby jak będzie to wyglądało. A jeśli chodzi o sterowanie, to tutaj mamy taki element graficzny, gdzie możemy przesuwać tę kropkę w prawo, lewo, do góry, co oznacza, że łódź ma płynąć albo do przodu, albo lekko skręcać w prawo, w lewo, ewentualnie do tyłu, bo też taka możliwość istnieje. No tutaj mamy pokazany już ten interfejs, też nie na łodzi, bo gdy byliśmy na wodzie, to nie udało się nam tego zarejestrować. Zresztą mieliśmy tam troszeczkę też i małą taką awarię, która spowodowała, że nie mogliśmy tych testów wszystkich przeprowadzić. No ale powiedzmy, te interfejsy tak mniej więcej wyglądają. Jakość zdjęć może nie jest najlepsza, bo robione troszkę na szybko. Tu widzimy coś, co było wcześniej pokazane. Tutaj właśnie ten punkt, który możemy się przesuwać, co powoduje, że łódź będzie płynęła w jedną albo drugą stronę. To jeszcze mówię, to nie są zdjęcia z testów na wodzie, to są raczej takie symulacje, ale pokazujące jak to działa, jak to będzie działać. No i tutaj mamy pokazaną mapę. Nasza łódka, ona jest troszeczkę większa, nie jest to w skali, ale jeżeli ktoś zna nasze okolice Rzeszowa, to rozpozna tutaj żwirownię. Więc sygnał GPS akurat tutaj też był zasymulowany. Na podstawie sygnału GPS jest określone jak gdyby położenie i przesunięcie względem jakiegoś tam punktu startowego. Stąd też możemy się przesuwać po mapie i rejestrować położenia naszej łodzi. Nie zostało to może na zdjęciach pokazane, ale w tym oprogramowaniu mamy możliwość również zadawania punktów nawigacyjnych, waypoints, które zamierzamy w przyszłości wykorzystać do nawigowania. Czyli użytkownik będzie mógł sobie postawić kilka takich punktów, przez które albo w pobliżu których powinna łódź się przemieszczać i dzięki temu możemy wyznaczyć sobie ścieżkę, po której łódź będzie płynęła. Jeśli chodzi o schemat blokowy autopilota, to został on mniej więcej składa się z dwóch regulatorów. Pierwszy to jest regulator kursu, drugi to regulator ścieżki. Pierwszy odpowiada za ustawienie względem kierunku północy tej naszej łodzi na podstawie sygnału żyrokompasu. Natomiast drugi regulator ma korygować kierunek, którym płynie łódka w przypadku, gdyby na przykład działały różne zakłócenia środowiskowe w postaci fal, wiatru, jakichś prądów morskich, rzecznych. Morskich to raczej nie, bo łódka jest mała. Nie powiedziałem, ale ta nasza łódka ma po prostu 3 metry, więc na morze to się ona nie nadaje, ale jak najbardziej na jezioro typu żwirownia czy choćby Solina jak najbardziej tak. Silniki elektryczne, więc po Solinie również będzie można pływać. Ten system składa się jak gdyby z takich kilku elementów. Oczywiście statek czy łódka to jest coś, co jest naszym obiektem sterowania, obiektem regulacji, na które wpływają pewne zakłócenia. Natomiast ten nasz autopilot to w zasadzie są to głównie te dwa elementy z lewej strony i to, co jest tutaj po prawej. Z lewej strony to jest regulator kursu, heading controller. No i po lewej stronie dodatkowy regulator ścieżki, track controller, którego zadaniem jest korygowanie kierunku w przypadku, no tak powiedziałem, zakłóceń, które oddziałują na łódkę. Oczywiście tutaj są pewne jeszcze blok związany, wykonujący pewne obliczenia, określający w którym miejscu znajduje się łódka, no na podstawie pomiaru sygnału z GPS, no tego co sobie użytkownik pozaznaczał na mapie, gdzie chce płynąć. Więc jeśli chodzi o sygnały, które są wykorzystywane, no to jest żyrokompas. Tutaj mamy właśnie korektę, odchyłkę od kursu, przy czym chodzi o odchyłkę liczoną w metrach, nie kątach, tylko w metrach. Natomiast track ref, no to jest zadany kurs wynikający z ustawień na mapie, z tych punktów nawigacyjnych. Nie będę może wchodził w jakieś tam szczegóły, a implementacyjne, no powiem tylko, że program Autopilota bazuje na tym, co wcześniej kiedyś opracowaliśmy dla środowiska CPDev, więc mamy już taki program Autopilota już opracowany. On był opracowany również przy współpracy, czyli dla firmy Praxis. No w tej chwili te prace zostały zawieszone, ale jak najbardziej mogliśmy, czy możemy wykorzystać to oprogramowanie powstałe w środowisku CPDev do tego naszego autopilota. No, z przyczyn takich troszeczkę technicznych wykorzystaliśmy, czy zaimplementowaliśmy to oprogramowanie w języku C, C++, a nie w ST z uwagi na to, że chcemy mieć mniejsze narzuty czasowe, żeby to działało szybciej, sprawniej, bo czasy cyklu obliczeniowego są tutaj bardzo istotne. Jeśli chodzi o identyfikację obiektu, no to wiadomo, ponieważ te regulatory kierunku, regulatory ścieżki to są regulatory takie klasyczne PID oraz PI. Regulator kierunku czy kursu to jest regulator PID, regulator ścieżki to jest regulator PI. No i trzeba wyznaczyć dla nich nastawy. Więc żeby wyznaczyć nastawy regulatora, wcześniej musimy przeprowadzić pewien taki eksperyment związany z taką metodą identyfikacji nazwaną zigzag. To są takie manewry, skręty w lewo, w prawo i na tej podstawie, w zależności od tego, jaka jest dynamika statku, no, są wyznaczane nastawy. Za chwileczkę jeszcze będzie pokazany rysunek. Generalnie co do zasady, przyjmujemy, że ten nasz model łodzi będzie z grubsza zgodny z takim bardzo popularnym modelem statku Nomoto, który jest po prostu zwykłą taką blokiem inercyjnym o pewnym współczynniku wzmocnienia K oraz stałej czasowej T. No, jeżeli ta transmitacja nasza odnosi się do prędkości skrętu, no bo tutaj mówimy o tym, jak szybko łódka będzie skręcać, no to jeżeli mówimy o skręcie, no to będziemy mieli zależność prędkości skrętu od wychylenia steru, względnie od orientacji kierunku. No jeżeli uwzględniamy jeszcze ten człon całkujący, no to wtedy ta transmitacja będzie wyglądała podobnie, ale troszeczkę inaczej. Więc zadaniem naszym w tej identyfikacji jest wyznaczenie dwóch parametrów K oraz T. Jeżeli będziemy znali parametry obiektu, to będziemy mogli wyznaczyć nastawy regulatora. Identyfikacja polega na tym, że wykonywane są takie nagłe skręty w prawo, lewo, oczywiście nie jakieś bardzo duże, to są kilkustopniowe wychylenia steru, powodujące, że statek zaczyna płynąć w lewo albo w prawo. Powiedziałem wychylenia steru, a wcześniej mówiłem, że nie mamy steru, mamy silniki elektryczne, ale można to przeliczyć, czyli natężenie, czy prąd płynący przez silnik wywołuje odpowiednią prędkość i to wywołuje pewną siłę i w zależności od tego, który silnik z jaką siłą pracuje, to będzie on wykonywał skręt albo w prawo, w lewo, więc będzie to jak gdyby odpowiadało temu, co realizuje, czy wykonuje, za co odpowiada ster. Dodatkowo w przypadku takich klasycznych łodzi ten ster wymaga, aby statek płynął pewną prędkością. Tutaj można powiedzieć, że nasza łódź może wykonywać manewry skrętu nawet stojąc nieruchomo, prawie że nieruchomo możemy tą łódką obracać, dzięki temu, że mamy 2 silniki. Więc wykonujemy manewry tam w lewo, w prawo, co powoduje, że łódka zaczyna tak się obracać. Raz w jedną, raz w drugą, ale nie w sposób gwałtowny, ale taki bardziej oscylacyjny. No i na tej podstawie amplitudy tego wychylenia, tego skrętu i czasu, ile to zajmuje taki skręt, wyznaczane są najpierw parametry obiektu, a później nastawy regulatora. I wykorzystujemy przy tym metodę Astroma-Hägglunda z roku 1984. Wykorzystujemy komunikację MQTT. Póki co zobaczymy, czy będzie tak docelowo, czy nie. Wybraliśmy tę komunikację dlatego, że MQTT jest stosunkowo lekkim, prostym w implementacji protokołem. Chcieliśmy to po prostu szybko zrobić. Ma niewielkie narzuty czasowe. No i ten protokół jest bardzo obecnie popularny, zwłaszcza w zastosowaniach związanych z internetem rzeczy, w IoT. Natomiast problem, który się pojawia, dotyczy tego, że w odróżnieniu od zastosowań IoT, tutaj będziemy mieli dosyć duży napływ danych. No, w takich popularnych zastosowaniach MQTT jednak te dane przychodzą dosyć rzadko, co wiąże się z tym, że nie ma dużych wymagań, jeśli chodzi o biblioteki, które przetwarzają te dane. W naszym przypadku okazuje się, że te popularne biblioteki nie do końca sobie radzą z dużą ilością danych. No i trzeba pewne specjalne zabiegi zrobić, żeby to uzyskać. Więc badana była biblioteka bardzo popularna PUBS Client, która jest uruchamiana bardzo często dla środowiska Arduino w sprzęcie związanym z Arduino. No i działa ona w ten sposób. Okazuje się, że ta biblioteka przetwarza każdy temat, który jest, każdą wiadomość, która jest przesyłana w jednym cyklu obliczeniowym. Tylko jeden temat, tylko jeden komunikat z danego tematu. Jest tam taka funkcja callback, która przetwarza te dane. Natomiast jeżeli mamy kilka wielkości przesyłanych jednocześnie z urządzenia na kilka tematów, to niestety, mimo że będziemy często wysyłać, na przykład co 100 milisekund takie komunikaty, ale jest ich kilka, no to niestety, ale przetwarzanie tych danych może zająć ponad sekundę. W związku z tym trzeba było coś zrobić, żeby ten problem jakoś rozwiązać. No bo wywołanie tego później jest właśnie przykładowo na przykład w ten sposób. Jeżeli klient jest podłączony, mamy połączenie, no to jest funkcja, która to przetwarza, ale jak się okazuje, mało efektywnie. Zatem w przypadku intensywnego napływu danych konieczne jest zredukowanie przede wszystkim liczby tematów przesyłanych wiadomości. Czyli zamiast pojedynczych wielkości liczbowych musimy przesyłać całą grupę wiadomości po to, aby w jednym cyklu obliczeniowym można było wszystkie te informacje przetworzyć. I drugą rzecz, którą trzeba zrobić, jeżeli mamy kilka urządzeń, które są podłączone w ramach systemu, no to trzeba po prostu kilkakrotnie wywołać funkcję, która służy do obsługi. Normalnie wywoływana jest ona jednorazowo. Natomiast jeżeli wywołamy ją kilkakrotnie w jednym cyklu obliczeniowym, to się okazuje, że kilka komunikatów jesteśmy w stanie przetworzyć w jednym cyklu obliczeniowym, co pozwoliło na w pewnym sensie rozwiązanie problemu. Zobaczymy, czy sprawdzi się ono do końca w tym rzeczywistym urządzeniu. Jeżeli nie, to będziemy próbować zmieniać komunikację na jakąś inną, być może inny protokół, być może inny w ogóle interfejs komunikacyjny. Na pewno będziemy chcieli również zrobić sterowanie przewodowe, w razie gdyby były problemy z bezprzewodowym, aczkolwiek główny nasz cel polegał na zaimplementowaniu protokołu bezprzewodowego, żeby ograniczyć liczbę kabli, i wygodę później przy montowaniu, demontowaniu urządzeń. Obecnie udało się uzyskać czasy rzędu 200-300 milisekund przy komunikacji z 3 urządzeniami, co jest póki co dla nas wynikiem zadowalającym i myślę, że Póki co na razie możemy przy tym zostać. Podsumowując, no, został opracowany system sterowania łodzią motorową z 2 silnikami elektrycznymi, 2 silnikami napędowymi. Mamy możliwość realizowania sterowania zdalnego zarówno w trybie ręcznym, jak i automatycznym, czy w trybie MAN, trybie auto, z poziomu interfejsu HMI, ewentualnie z komputera pokładowego, bo ten nasz komputer pokładowy również może sterować silnikami za pomocą joysticka. Tam może nie powiedziałem tego, ale tam u dołu poniżej ekranu był joystick, którym również można sterować. Jeżeli byłaby awaria systemu komunikacji, no to mamy możliwość sterowania ręcznego bezpośrednio na sterownikach przy silnikach. W oprogramowaniu Autopilota zaimplementowaliśmy 2 regulatory. Jeden to jest regulator kursu, drugi regulator ścieżki. No i do wyznaczania nastaw regulatora wykorzystywana jest identyfikacja bazująca na wykonywaniu manewrów zigzag. Jest to jedna z podstawowych metod do właśnie wyznaczania, do identyfikacji parametrów łodzi i nastaw regulatora. Ja dziękuję, tyle z mojej strony.
Thank you very much. Is there any question on the room? Czy są jakieś pytania?
Okay, just a side note, Andrzej said about tests in real environment. Since we are in Rzeszów and we have the sea, I think 700 kilometers away, we have to deal with the local water reservoirs, and we until now we were using Żwirownia lake, which is rather a pond used by citizens for sunbathing, swimming, etc. We had to get special permissions from the city authorities to use this for our, let's say, research, and also we have to have the permission to enter there by car, because our boat is small, but it's not as small as we cannot put it into a trunk of our cars. We had to order special truck to transport the boat. And as always, not all that we expected to test was done. We had some problems. Fortunately, we were able to get back to the shore with just 1 engine. So this is just the side note. Okay, Janek?
Okay, any other questions, comments? I don't see. We are going to close the second session on our conference, so it's our time for a lunch break. So enjoy the meal.
Yeah, all of you are invited, and after the break at 14:15 we have 2 other speeches. The first is by Dariusz Rzońca and the second by Nino Topuria. So we will see you here at 14:15.
Hello again. Welcome on third session of the POUS conference. The session is entitled Utilities. And our first speaker will be Dariusz Rzońca from Rzeszów University of Technology. And he will say about improvement of communication efficiency between PLC and HMI in Modbus protocol. Dariusz, the floor is yours.
Thank you very much. I'm glad to have an opportunity to say a few words about the communication in Modbus protocol between the PLC and HMI, and to advertise a possibility to improve the efficiency of such communication. My presentation will be presented on the following schedule. After the short introduction, I will say a few words about the HMI visualization in CPDev and about the data exchange between the PLC controllers and HMI panels. Then I will show the possibility about improving the communication efficiency by grouping of registers, and finally I will sum it up. Let's analyze the typical example of control process. We have one or two tanks, and our PLC have to control the dilution, mixing, heating, filling of these tanks. Let's also imagine that we have a visualization of such a process on some SCADA. In this example, it's in CPDev, in CPVs. It's part of CPDev's engineering environment. Such a visualization can be done on a PC computer, on a HMI panel. As data source can be simulated values or values read from hardware PLC. And if we use hardware PLC, we need some kind of data exchange method to read the values from the PLC to be able to display it on the HMI panels. Such data exchange method requires some communication protocols. Typically, industrial communication protocols are used, like Modbus, Profibus, etc. It can be communication on a field bus, or nowadays on industrial Ethernet. Let's focus on Modbus. Modbus protocol implements some so-called functions, and the most important functions, the most typically used functions, are presented on the picture. We have some functions to read binary inputs, read so-called registers. It means variables, 16-bit long variables, and to write binary or analog value. We have also functions to write multiple binary or multiple analog values. How's the HMI connected to the PLC? We have two possibilities, two cases. On the first example, the HMI can read values from the PLC periodically, so-called pooling, and in such case the function number 3 will be used to read the values from the PLC. Alternatively, the PLC may periodically send data to the HMI. In such case, the PLC will be the master device and HMI will be the slave. In this second case, the function number 6 and function number 16 will be used. Function number 6 allows us to write a single register, while function number 16 allows us to write multiple registers in one data frame. Let's analyze the Modbus frames involved in such communication. In case of function number 3, so read analog registers, we have a data frame which is sent by a master device where the starting address from which we want to read the values are indicated and the quantity of registers we would like to read. And the slave device responds with such frame. The length of such frame depends on the amount of data returned. So the amount of registers, the quantity of registers we would like to read. In the second case, we have two functions, function number 6 and function number 16. In case of function number 6, write a single register. The request and response frames are identical. The master device sent value to be written at the given address, and the slave device responds with exactly the same frame. In case of write multiple registers, so function number 16, the length of data frame in request depends on the number of registers to be written, while the response, the length of response is constant. It's just indicated that all the registers have been written correctly. Let's focus on the second case. And we can see that the transmission of numerous registers in one frame requests that those registers will be consecutive. We can see in one frame only adjacent registers, not any registers we choose. So it will be good for us if all registers we would like to transmit are adjacent to each other in the controller's memory. But unfortunately, it's not always possible. For example, we may have some variables which are complex variables, like arrays, structures. In such case, we cannot arrange all registers we would like to transmit next to each other. Moreover, sometimes we have some values which are used on many screens. And again, we are not able to arrange those registers to be adjacent to many other registers. So, when we look at the address space in the controller, we may see that sometimes the variables we would like to transmit, we would like to send to HMI panel, are not adjacent one to each other. So let's imagine that we would like, for example, to transfer the value of volts and the value of temperature in the tank. And the addresses show that there are some other register between those variables. And we have two possibilities. We can use two separate data frames to send those values. In one frame, this variable will be sent, and in the other frame, the next variable will be sent. Or we may send both variables in the same data frame, but in such case, we will have to send some redundant registers, unnecessary registers as well. So we may choose to send this part of controller's memory in one data frame, along with some unnecessary redundant registers. And the question is, which case will be better? If sending some unnecessary registers allows us to improve the data transfer time, it might be better to send some unnecessary values and just discard them. So let's analyze it. We have to to calculate the time needed in both cases. So there are some denotations which will be used in the following equations. I will not discuss those equations in details, but if some of you would like to ask me questions, I will be more than happy to answer how it was calculated. But let's see what are the results. In first case, we have two separate write single register commands, and we need this amount of time. In the second case, we are using only one command, write multiple registers, and in such case, we are sending redundant registers, unnecessary registers, and the required amount of time is as follows. We are calculating the difference between those two values, and we can see that sometimes, indeed, it's better to send everything in one frame along with some unnecessary registers, but the required time will be less than if we choose to use separate commands. We can see that if the number of redundant unnecessary registers equals or is less than 9, the second case will be better. And it doesn't depend on the used baud rate. If we would like to send more than 9 unnecessary registers, it depends on the baud rate, time of transmission of single byte, and time required for the master and the slave to generate the request and the response, respectively. So we may see that the dynamic selection of the transmission method is a good way to go. It may sometimes shorten the cycle time need for communication. We can see this in the following charts. We have two lines. The first is for 9,600 bits per second, and the green line is for the other transmission speed. And we may see that depending on the number of redundant registers sent in one frame in the second case, sometimes it's in fact better for us to send those values in the one frame. But for the small transmission speed, for low number of redundant registers, it's better to send it in one frame, but for high values of redundant registers, it would be better to send it in separate data frames, because the difference is less than 0. But for high transmission speed, even for very high number of redundant registers, it would be better to send everything together in one data frame. Similarly, we have a second chart where such a difference is calculated for the higher speed, higher baud rate. And we can see that depending on time required for master and slave and the number of redundant registers, sometimes it's better for us to send the values together or separately. But everything is easy to calculate when we are considering the transmission of just 2 registers separated by some number of redundant registers. But in typical case, we are not sending just 2 registers, where the better case can be easily identified. We are sending the several dozen registers, maybe several hundred registers. It's not so easy to calculate the optimal solution in such case. it's an optimization problem where various algorithms are possible, like constraint programming, mixed integer linear programming, tabu search, some heuristic rule-based algorithms, and so on. And for such complex case, we have analyzed it and prepared together with my colleague Andrzej Bożek a publication which is currently in review, and I hope it will be published soon. So if you have any questions about it, I will be happy to share the publication with you. Okay, to sum it up, I've shown the influence of the arrangement of variables that can impact the amount of time needed for transmit the data in Modbus protocol, and sometimes it's possible to improve the efficiency of such communication using appropriate grouping of registers. Sometimes it's better to send some unnecessary, some redundant data, but achieve better time parameters. Thank you very much.
Thank you, Dariusz, for your speech. Is there any question on the room?
If there are any questions, I will be more than happy to answer.
Yes, there is.
Sorry, more than a question is a comment. First, it's quite interesting for your investigation because we used to use Modbus inside the substations only for those things that are not critical because many other data is subject to criticality, and then we use some other specific protocols. Okay? Just to mention, in some protocols they have the same issue. So they went to a solution where you configure data sets in the device. So then you can define a data set 1, data set 2, so different sets of data, and then you pull one set of the data and you get directly what you get. No? But I mean, in terms of Modbus, which is a very popular protocol due to its easy integration and it's quite plain. Then we can see this kind of problems that make us to think more about and how to pull it. Okay, just was a comment. Thank you.
Thank you very much. As far as I understand, such data sets requires the values to be copied to some separate memory region to be transferred together. I'm aware of such solution, but the problem is that such copies require some amount of memory and some amount of time to copy it. So if we have large data sets, multiple copies of it will be sometimes maybe unnecessary.
This is thinking on devices that the memory is not a problem. So then you can have more complex protocols which you can optimize the communication because you have more CPU and more memory. So for sure, Modbus is very good because with a very easy, very thin microcontroller, you can implement very easily Modbus slave with no consumption, you know. So, okay, thank you.
Thank you very much.
Okay, is there another question? Okay, thank you, Dariusz, once again. And our next speaker is Ms. Nino Topuria, who will be presenting Power Automate robotization of business task.
Thank you.
Okay, Nina, the floor is yours.
And next presentation about robotization of business tasks. Robotization of, this is the description of, oh, okay. Robotization of business tasks refers to the process of automating various aspects of business opportunities using robotic technologies, software, and other forms of automation. It involves the use of robots, both physical and virtual. Okay. Robotic process automation involves the use of software robots or bots to automate repetitive and rule-based tasks. AI and machine learning technologies are often integrated into business processes to make intelligent decisions. Physical robots and chatbots. In manufacturing and logistics, physical robots are used to automate tasks such as assembly, packaging, and etc. The robots can work alongside human works in collaborative or fully automated environments. And what is chatbots? Everybody know. Workflow automation. A business process such as approval workflows, document routing, and task assignments are automated to streamline operations. Data integration and analytics, business intelligence. Okay. What industries will benefit from automation? There are two types of automations and industries can take advantage of. This is process automation and industrial automation. Leading companies switching to automation, this information are collected from various sources. JP Morgan use intelligent document processing, review commercial loan agreements. Microsoft use intelligent document processing for scan and process content. And previous presentation, we can see this. Alibaba, hyper-automation, generate product description for clients, also for shipping, logistics, and customer shopping predictions. Coca-Cola, on-demand shipping requests, SAP invoicing processes. Mercedes-Benz works alongside humans to complete alterations, customizations of cars. Airbnb, search, booking, and payment processes. Netflix, testing. Why so? Testing to ensure compatibility and portability. Adidas, standardize and automate process across departments to reduce time to market. Audi, simplify finance department deals and processes. Philips, image recognition, computer vision, data mining to compare patient records with a global database of patients. Uber, customer transactions and invoices. What is the best business process management software? This is a list of business process management softwares. You can see Power Automate in the second position. And now we speak about Power Automate. This is a Microsoft product. Okay. Excuse me. Power Automate can automate repetitive tests, and here are 6 Microsoft Power Automate example workflows that gives a basic understanding of how you can use the intelligent automation platform. Think of any task that requires you switch applications. The task can be automated with Power Automate workflows. What is Power Automate workflows? We can see in previous presentation. This is an example. Send a tweet when a Google Sheets row is added, for example, or send an email when an attachment is received. What is it? Who can use Power Automate? Anyone can use Power Automate. This is no-code, non-code, or low-code platform to automate any kind of task which is manual, repetitive, and follows a set of rules. Here are the best use cases for using Power Automate. Why so it? I don't know. Freelancers, who can use this? Freelancers with small team or are also, you know, business makers and generally work with a small team or by themselves. Freelancers can use Microsoft Power Automate to automate manual tasks like setting up autoresponders, alerting when they receive a message on email, and so on. Managers. Managers working to enterprises or brands to use workflow management software. Finance department users. A lot of finance tasks are manual. Power Automate can be used to set up workflows for approval processes, invoice processing, and more. Business person. They can automate multiple aspects of their business with Automate workflows. How can we use Power Automate? Okay. Launch Office 365 once more. Portal Office.com. Here we have Power Automate. And templates. Each template has name, so you have to find more suitable for your needs, or you can search it, maybe for Gmail. Save Gmail attachment to your Google Drive, or save Gmail attachment to a Dropbox folder. say Gmail attached to OneDrive for business, and so on. Okay. You have if you want to create a new template or new workflow, you choose create button. You have to choose create button. Then choose instant cloud flow or scheduled cloud flow. What's the difference? Instant scheduled cloud flow. If you choose scheduled cloud flow, you can use it for starting. You can point starting date and time and repeat every. You can select minutes on days or months and so on. Okay. Then cloud flows are online flows that start with a trigger or some action. What is a trigger? If we want this is the trigger. If sentence begins with when, this is a trigger. Okay. Then instant cloud flows when you want to take action and click a button. Then automated cloud flows, a series of sets when your conditions are met, and how it can create it. Scheduled cloud flows, okay. Desktop flows, and business process flows. Then, using Microsoft PowerPoint, automate templates. First example, Gmail. We will save our Gmail attachment into our Google Drive folder. Go to template, maybe. Gmail, search in Gmail. In a Google Drive folder, choose. You will ask to link your account after selecting the template. Okay. Two green ticks appear in front of each connection. Choose edit. This is blocks when a new email arrives. Apply to each attachment, create a file. That's all. That's all. Then select the proper variables. Let's say you want to receive a notification every time this flow occurs. Then seven processes you should automate using Microsoft Power Automate. Automatically save email attachment. Who this could benefit? Account managers. How can it help? When attachments get sent regarding a client, Power Automate can save them into the relevant SharePoint folder. What is SharePoint? SharePoint is Microsoft tools for designing sites and corporate web portals which do not need coding. How launch SharePoint? This SharePoint. Many big organizations such as Starbucks, Adidas, and etc. are using SharePoint. excuse me, how we can create site. Only choose create site. Named it. We have two. We have team site and communication site. Team site for this private space to collaborate with your team, and communication only for information. We choose team site. There are many templates, and use template. Test. Pay attention, we are working online. We do not need to install any software. Add members, now we have net members. Need some time. Finish. We have home page. We can add pages. Blank or template, maybe blank. You can add title. And publish. Add page to navigation. We have page of conference here. One of the most important things is create lists. List someone as an Excel table, but in the web. Something. Products or employees. Add name, surname, salary, currency. And so on. If you want to add the row, choose Edit the Grid View, Mr. or Mrs. It's Georgian surname and surname. Salary. You can add them. Other types of columns, if you need. Okay. Okay. Account managers can use SharePoint. And there are many templates for SharePoint. this description of SharePoint, this information from Microsoft documentation. SharePoint and its role in improving digital transformation are document management, process automation, data integration, intranet and communication, mobile and remote access, integration with 3065. How can we design mobile application? Choose integrate and Power App. Okay, this is mobile application, and we can add a new row remotely. Test, choose plus, title, salary, and click here. New add is added, new row is added. So this application is very comfortable for managers if they are working remotely, or any other employees. Okay, you can add a new screen from blank or from template. And you can add a button, new button, insert button, we have to name the screen, rename, home, page, okay. Home page. And for this button, we need function navigate, navigate to our screen named material pattern. And here, navigate. Here. That's all. Test our mobile application. It's working. Okay. Finally, choose save. And publish. Then we have to find our application, launch Power App, apps, here we have our application, play. Here we have download part, and you can download Android version or iPhone version. That's all. Okay. What is SharePoint? We know. We have on-premise SharePoint, if SharePoint is intranet on a local server. We have online version under subscription of 3065, Office 3065, and hybrid version. They cost $5 per month. How create site we know. And then overview, the brief overview of templates. Manage holiday requests and approvals. Can use employees and managers, this template. Request approval for new documents and notify employees via Teams for project managers. This template. Then get a push notification when you receive an email from your boss, this template. Social media, stay on top of social media, this template. Oh, excuse me. Automating the onboarding process for new employees, and so on. Question about how can we use AI? Can we use AI for critical situation? For critical situation, we use app. Azure IoT Central. Azure it's a Microsoft platform. Okay. This is platform where you can test various types of IoT devices. Choose build an app, create an app. You can change the name if you want. IoT device. It's not mandatory. Pricing plan. For devices sending a few messages per day, 2 free devices. But these, by my subscription, I can use this platform only 1 week without paying. Select subscription. This Azure, Azure Microsoft Azure for you know Amazon Web Services, and Azure is Microsoft platform which offer cloud services. So I have this subscription, but not in no. Okay, you can use, if you have subscription, you can design a new application. You can use for testing any IoT device. You can create new job here, and Power Automate has ability transfer the data from IoT Central to an Azure SQL or other databases. Okay. It's working. Choose templates and choose IoT. Run a custom action when IoT Central rule is fired. And Central action rule is fired. The rule can create in that platform, and then you can add data in Azure SQL database or in Excel, only Dataverse. So for critical situation, we use this platform. Okay. Thank you for attention. Maybe questions?
Is there any question on the room? Okay, I have one. You show an example where the attachments were automatically saved to the Google Drive.
Yes.
And assuming that we can share the Google Drive with other person, it can be security drawback, because when somebody may send you an infected file, the script will automatically send this virus to the drive, and someone else can accidentally run this virus.
No.
No?
Microsoft tests all files.
Yeah, but also what was in the past.
Viruses.
Yeah, but we can imagine that somebody is trying to hack us, and in such situation, he tries to send a document which is something like PDF file, and looks like PDF file, but in fact it is a Trojan horse. So without human verification, it is a security hole. So there's a possibility that someone can infect your computer or steal your data just by such automatically provided actions.
As I know, Microsoft testing all files.
Yes.
But
they know they only know the viruses which are known, but they don't know the viruses which are new one. So this is a little bit
security.
Security.
Very important.
Yes.
Nowadays, yes.
Exactly. Okay. Thank you. Is there any question? Okay, so thank you once again for interesting presentation, because to be honest, I never ran this application like Power Builder. And you showed that building a very simple application which collect data from the many clients using the mobile phones is very easy now.
This is a solution for organizations, but every can use it. Everyone.
Exactly, as everybody can be a programmer. Okay, thank you.
Thank you.
This was our last presentation. So to sum up, our conference is going to be closed. So once again, I would like to thank you, all of the attenders who came here and participate in the conference. Also, I would like also, I would like to thank also the speakers for preparing their presentations. And the last one, the important person, the Polish Ministry of the Science and Education, who sponsored the event. So now I must announce that the POUS 2023 conference is closed. So have a good night and see you on the next edition. Goodbye. No to dziękuję Państwu za udział. Także do zobaczenia w przyszłym tygodniu.